Hello guys, this is a follow-up of the previous video about stoichiometry and ratios that we follow into a chemical reaction, or in other words, a recipe, right? It also works for cooking recipes. So right now we're going to be working with this equation over here, which is 2 aluminum plus 3 chlorine gas produces 2 aluminum trichloride. So on the handout or the problems, these chemicals have the states with them, some states, right? Gas, but we don't really need those states right now. They're going to be useless in the calculation that we're going to be doing. Okay, so we don't really need those states. I'm just going to avoid those to avoid it being too clumpy. So the question that is being asked is, if I have 13.5 grams of aluminum, which is the first reactant, okay, how much am I going to produce, or how many grams am I going to produce of, or do I need from chlorine gas, and how many grams am I going to produce of aluminum trichloride? So I'm trying to find the equivalent quantities in grams. Okay, now the conversion is not as simple as converting moles to moles. In the previous video, I showed you how to convert, how to do stoichiometric calculations from moles of A to moles of B. Excuse me. And so these are fairly simple calculations. All you have to do is deal with these numbers, these stoichiometric coefficients in front of the chemicals in the chemical reaction. Okay, but right now we're given the things in grams. And why are we given the things in grams? So for example, if you go to a hardware store and you want to buy some nails, you don't go there and say, can I have 10 nails, right? Or you don't go and say, can I have 5 nails? So you have to go there and say, can I have a pound of nails, right? Or can I have 1 kilogram of nails? So they sell you by the mass because it's easier to weight stuff than it is to count individual items. So that's why this problem is talking about grams instead of moles, right? Moles are used to count, grams are used on a measurement of mass. So we have to, before we start doing any mole to mole conversions, we have to convert those numbers to moles, those given numbers. Okay, so how do I convert 13.5 grams of aluminum to moles? You need a specific number that we call the molecular weight. So where can I get the molecular weight for now? All you have to do is Google. Okay, so you're going to Google the molecular weight of aluminum, and this is the number that's going to pop up. Okay, so once you Google molecular weight of aluminum, 26.98 is going to be the number that's going to pop up. Okay, and you do the same for the other chemicals. The chlorine gas, molecular weight of chlorine gas at 70.91, and molecular weight of aluminum trichloride is going to be 133.34. Okay, so those numbers, they come from Google. And what does those numbers mean in terms of the stoichiometry? It means that 1 mole of those reactants, or those reactants or products or chemicals, it has a weight of 26.98 grams. Right? 1 mole of chlorine gas has a weight of 70.91, and 1 mole of aluminum trichloride has a weight of 133.34 grams. So this is what it means. Okay, so instead of doing a mole A to mole B conversion like in the previous video, we're going to add an extra step in here. So we're also converting from grams of A to moles of A before. And then at the end, the moles of B, we are converting to grams of B. And that's what we're going to use those molecular weights for. Okay, so let's see how we can convert the grams of A. In this case, this is going to be grams of aluminum, the given number. Let's see how we get to convert all the way to grams of B, or grams of the other reactant, which is a chlorine gas in this case. Okay, so let's start the dimensional analysis. I'm going to scroll up a little bit. So my first number in the dimensional analysis, grams of A, is going to be 13.5 grams of aluminum. That's the first number, and then I'm going to convert, do the first conversion, right? Grams of A to moles of A. So grams of aluminum to moles of aluminum. And this is where I'm going to plug in the molecular weight. That's the number that I'm given. Okay, first molecular weight says that 1 mole, so 1 mole equals 26.98 grams. Okay, I'm putting the grams on the bottom because I want the grams of aluminum to cancel out on the first step. So as the first conversion, if I were to stop there, the result will be moles of aluminum and will be good. Okay. The second conversion that we're doing is moles of A to moles of B. So these are my moles of A. I have to convert those to moles of B, which is chlorine gas, right? We're trying to convert to grams of chlorine gas, so we have to convert to moles before. So I'm converting to, well, from moles of A, which is aluminum, to moles of B, which is the desired chemical, right? Chlorine gas, CO2. So from moles of A to moles of B. Now, where am I going to take this number from? In the previous video, I showed you where to take this number from, and these are the stoichiometrical coefficients that I have. Okay, so if I scroll up, the relationship between moles of chlorine and moles of aluminum are going to be those numbers over here on the top. So moles of aluminum to moles of chlorine, right? 2 to 3. So it says that 2 moles of aluminum, so my number with aluminum should be 2, and it says that the number with the chlorine has to be 3. So that's a stoichiometrical conversion that I'm doing. Okay, I'm using those numbers in the chemical reaction now. Okay. So why am I putting aluminum on the bottom? Because I want aluminum to cancel out, right? Moles of aluminum on the top with moles of aluminum on the bottom. If I were to stop there, the result would be moles of chlorine gas, of course, but we're not trying to convert to moles of chlorine gas. This is just a bridge, right? We need to convert to grams, to moles, because once we have moles, we can easily convert to grams of CO2. So the next conversion is going to be from moles of B to grams of B, right? So from moles of chlorine gas, which is going to be the result that I have right now on this number over here. So from moles of chlorine gas, we are converting to grams of chlorine gas. Now, what are the numbers that I'm going to place in here? The molecular weight of chlorine gas, right? So it says that 1 mole is the same as, or it equals 70.91 grams of chlorine gas. Why am I placing moles of chlorine gas in the bottom? Because I want the moles to cancel out. Okay, so moles of chlorine gas cancel out with moles of chlorine gas. Of course, the numbers are not being canceled out, right? The numbers, you have to carry those forward. Okay. So I analyze and I see that the resulting unit, grams of chlorine gas, this is the unit that I'm looking for, right? Grams of chlorine gas. So they should give me the result. All I have to do is the math. So I'm going to multiply all of the numbers that are on the top of my dimensional analysis. Let's scroll up a little bit, right? So that's 13.5 times 1, so the numbers in the top, times 3 times 70.91, and we are dividing by 26.98, and we are dividing by 2, we are dividing by 1. Okay, so the result over here, if you do this operation correctly, is going to be 53.2 grams of chlorine gas. And this is the first result. What this means is that if I react 13.5 grams of aluminum, it is going to produce 53.2 grams of chlorine gas. Okay, so this is the first question. This is the first thing that I'm being asked. How many grams of chlorine gas am I going to produce? And the other question is, how many grams of aluminum trichloride I'm going to produce also. So I have to do this whole calculation again, but with the numbers for aluminum trichloride now. So let's see how this is going to look like. Let's use a yellow color now for this conversion. Okay. So again, I'm going to start with the given number, which is 13.5 grams of aluminum, and this is what I'm going to convert all the way to grams of B, which is in this case is going to be grams of aluminum trichloride. Okay, that's the second conversion that we're doing. So the first thing that we're going to do, I'm going to write that sketch again over here for you guys to see. So our solution map, or our plan to solve this is going to be grams of A. Again, they go to moles of A, and then we do the stoichiometrical conversion, moles of A to moles of B, and then we convert from moles of B to grams of B. Okay, this is what we're doing. New problem. Okay, so I'm going to take the same given number, 13.5 grams of aluminum, and I'm going to start doing the conversion. So the first conversion that I do, grams of A to moles of A. So grams of aluminum to moles of aluminum. That's the conversion that I'm doing, grams to moles. Where am I going to get these numbers? What's the comparison between moles and grams? If I scroll up, 1 mole is going to be 26.98. And can you see this looks really, really similar to the previous problem still, right? So 1 mole is 26.98 because we're starting with 13.5 grams of aluminum. The next conversion that I'm doing, well, of course, you have to cancel out the units, right? Grams of aluminum, grams of aluminum. The next conversion is going to be moles of A to moles of B. So moles of A go in the bottom, so they cancel out. Moles of aluminum. And on top, moles of B, in this case, is not going to be CO2, but it's going to be moles of aluminum trichloride. This is the other number that I'm looking. Okay, so where am I going to get this relationship of these numbers? From the chemical reaction. I'm going to scroll up again. I see the ratio between aluminum, that's a 2, and aluminum trichloride, that's also a 2. So I have to plug in those two numbers into my dimensional analysis, right? So 2 for aluminum and 2 for aluminum trichloride. That's the next conversion. Of course, you have to make sure that you cancel out units, moles of aluminum, moles of aluminum. And the final conversion that we're doing, from moles of B to grams of B. So from moles, I'm going to do the conversion right. From moles of aluminum trichloride, which is moles of B, we are converting to grams of aluminum trichloride. Okay, so what is my relationship between moles of aluminum trichloride and grams of aluminum trichloride? Again, I'm going to scroll up a little bit, and there's my molecular weight. This is the number that I need. 1 mole is 133.34 grams. So 1 mole is 133.34 grams. So these are the numbers that I have. And of course, you have to cancel out units, moles of aluminum trichloride, moles of aluminum trichloride. And the final result of doing all of this math should be grams of aluminum trichloride. So let's see what the result is going to be. So you have to multiply all the numbers on the top and divide by all of the numbers on the bottom. The numbers on the top, the first one's 13.5 times 1 times 2 times 133.34, and you are dividing by 26.98, you're dividing by 2, and you're dividing by 1. And the result of doing this mathematical operation is going to be 66.7 grams of aluminum trichloride. So those are the two answers that you're looking for in the handout, 53.2 grams of chlorine gas and 66.7 grams of aluminum trichloride. So this is a grams to grams conversion. It involves molecular weights. It involves a slightly longer step than mole to mole conversion. So in the problem, you're given moles and you're asked for moles, and that's the shortest path, right? So moles of A to moles of B, and the only conversion that you need is going to be the stoichiometrical conversion. But if the problem is giving you grams, then you have to be careful. So when you're given grams, you have to follow this path over here, right? From grams to A, from grams of A to moles of A, and then from moles of A to moles of B, that's the stoichiometrical conversion, and then from moles of B to grams of B using the other molecular weight. Okay, so I'm gonna put another video which is gonna talk about limiting reagent and percent yields, and this it is basically this stuff where we're gonna add something else. Okay, so make sure that you are doing your dimensional analysis correctly. So this is the dimensional analysis, so that the units are going to be canceling out and they're going to guide you through the path into the result.